All right, I'd like to introduce Edward Chenard. Edward is the head of Cyberian data. Within that space, his specialties include strategic planning, business-aligned technology roadmaps, transformational change programs, data governance and stewardship, data quality, measurement and continuous improvement, data science leadership, taming data chaos in a large and complex landscape, enterprise architecture, business intelligence, and big data management. So a lot of experience in data. Edward has also been a gigantic supporter of MnNamara from way back, from what, maybe 5-6 years now, maybe? 5 years, so a longtime supporter of MnNamara. And he is here to share with us how to navigate strategy and governance, the arena that 80% of the data science teams fail to navigate well and consequently fail to deliver business results on.
Well, thanks everybody. I know I'm holding you up between beer, so it's okay. I only have 57 slides to get through. Just kidding. This presentation, for those of you that may have seen last year's presentation on the softer side of data science, it's sort of along the same lines. That the information in this presentation, again, I'm trying to take us to a level where I believe data science is really going instead of just talking about where we are today. And originally I was going to call this presentation Welcome to the Dark Ages of Knowledge, but I thought that was a little too clickbaitish. So I just kept it to something a little bit more plain. But in a lot of ways, that really is where we're at today, where we have tremendous tools and we have tremendous sets of data, but we really have a shortness of understanding of what it all really means to our organizations. And when I put this presentation together, I really focused a lot on what was called the governance aspect of things, but also something that, for lack of a better term, I'm just calling it data strategy, because for the most part, it's still something that is being formed today. And that's because, in a lot of ways, data science has failed us. The quote about 20% success rate, that's actually an old one from 2 years ago. It's actually a lot worse than that now. Gartner recently did a study where really the success rate based off of how you measure business success in terms of executives saying, yeah, we made money with our data science projects, it's down to 8% success rate. So we're in the single-digit success rate, and yet we're spending tons of money on it. Something is clearly not working. And where we've gone with data science in the past few years, something that I've been able to watch since I've been in this space for quite a while, we spent a lot of time focusing on the coder and the statistician and saying this is the core of data science. But we've realized that isn't working quite well for us today. And instead of trying to expand, most teams are really just doing what I call a one-hand clap, where they just double down and just keep adding more and more to that complexity of that area, but it's still missing the mark. Because at the end of the day, data science it's really a product, it's not about development work. Because it's a product, you have to treat it in a product way in terms of how you grow the team, grow the concepts in the space. But because what we define as a product has also changed, those traditional rules of applying your traditional product management techniques are also failing us in a lot of ways too. That's where data governance has come into the picture, where a lot of companies are now using data governance in its traditional sense, where you see things like risk mitigation, team building, legal and ethics. Your traditional data governance domain. We're seeing that there is some success for, and that usually comes into the area of like data cleansing, keeping your data sets well maintained and regulated so that you don't get sued. And that's very important as well. But the problem with that also that I've run into is we're still not getting to the core of why are we having failure. Because all that the traditional data governance is doing is really being a risk mitigation factor for sloppy work in data science. once you take care of that, we're still at a point where a lot of data science teams where they have a data governance in place, they're still having a high failure rate. And why is that? And the more I started looking into that space, the more I started to realize that there's a key aspect of what we're missing, and that is really the human principle aspects of things. When we look at data, what are we really looking at? We're looking at human activity. There's a quote that says, "History is the study of humanities, but data is the study of human activity." And often when we're looking at our data sets, that piece of the equation is often missing in terms of what we're looking at. We forget that data actually has people behind it, and there's actions that those people took, and there's reasonings behind why those people took those actions. And that's often why we see that there's a lot of failure within data science. But once you start adding that piece in there, you start to see that the failure rate starts to go down and success starts to come up. So what I've seen with the different teams I've worked on is I was able to distill down, these are the different areas in terms of human principles around data science that seem to play a really pivotal role on whether or not you have success or failure with your teams. And they're all quite connected to what I call data strategy. And I call it that because, frankly, I couldn't find a term that described all of them. And as I talk with guys like David Quimby and Dave Mathias all the time. They'll tell you, I am not the person to come up with terminologies to naming conventions. So I use something quite basic, data strategy. Because in some ways, it does fit quite well. And I kind of want to go, I'm going to go through all these different aspects with you in terms of what do they do and why are they important. So the first one, expertise governance, or what's also called expert intuition. Now everybody likes to believe that they have expert intuition, but honestly very few of us do. In the world of machine learning in the Twin Cities, I've run into 3 people that are so good at machine learning, they have expert intuition. And this is, they have so much experience in the space that they can literally look at a problem and tell you exactly what's going to happen based off of their experience and knowledge. They have that much knowledge of the space, and there's very few of us that have that. I myself wouldn't even put myself in that category when it comes to machine learning, because to have that, you literally have to spend like 10, 20 years of doing this work over and over again on a daily basis and literally have a passion for it. And also there are some fields that just do not lend themselves to it. There's a reason why tons of people did not win Powerball yesterday. You cannot have expert intuition on picking lottery numbers. There's too much randomness in it. But you can have expert intuition in figuring out who's going to purchase a product, because there is actually a lot of patterns in there. We're creatures of habit, so it's easy to figure us out. But things like stock picking or Powerball number picking, it just doesn't happen. So one of the things I've also run into is when it comes to expert intuition, there's something that we often run into, and it's called the frequency illusion. Also called the Baader-Meinhof effect, but why somebody would name it after a West German terrorist group from the 70s and 80s, I never figured out. So I stick with the frequency illusion. That is something that, when it comes to expert intuition, I often see a lot where people believe because they've seen something over and over again, that must make it true or valid. And that's generally a false assumption to make. Because you see something over and over again, for example, a good example was Spark. At one point, Spark was a tool that came out, started playing around with it in 2013. It came out in 2012. And then all of a sudden, in late 2014, everyone was like, we need Spark. Most corporations really did not understand the business case, but because they saw Spark left and right, it was like, well, we need Spark. So they invested tons of money in a Spark implementation, and then it sat around collecting dust because most of the people in the organization didn't actually know how to use it. That's the frequency illusion, which comes into a lot of play when you're talking with networks. Now, I don't mean networks in terms of technology, but networks in terms of people. Today, our networks are not the same as they used to be. In the past, Our networks around certain topics used to be experts. You might have a group of professors that studied philosophy, and they would form a network and talk with each other and come out with interpretations of philosophers in the past. Today, our networks are quite different. There's Facebook groups on Aristotle, and you have high school kids who basically just read it in high school class talking about Aristotle. The problem with that is our networks today are often very persuasive based. So somebody who's really good at persuading people but not factually correct can have a lot of influence over how things are interpreted today. And that creates networks that are very fluid, very dynamic, and often very chaotic, and in a lot of cases, just wrong. The wisdom of the crowd is not always going to be wisdom-based. It's really going to be a popularity contest. So our interpretation of networks has really changed, and that's created a lot of problems in terms of how our data science communities are working as well. We've seen this where the data scientist is interpreted as someone who's really good at coding and stats. Why is that? Has anybody gone out there and tested whether or not that's valid or not? Actually, when I was at Target, we did test that, and we realized actually sometimes that is true, but oftentimes when you're dealing with social recommendation engines, the person who comes from the social science field is the best person that you need on that team, not necessarily the coder / statistician. But because of this whole persuasive effects of networks, you run into something called the Diderot effect. Now, Diderot was a French aristocrat from the 1700s. Somebody gave him a new robe that he loved a lot, and then he said, all my stuff is horrible in comparison. I need to buy all new stuff to match my new great robe. So he went out, bought all new things for his house, went into debt, and he realized, hey, I used to be the master of my old robe, but now I am the slave to my new robe. That same concept falls into play when it comes to our purchasing behaviors today. You see this a lot with data science teams where they do fall into the Diderot effect quite often, where all of a sudden we need a new database set, we need a new cluster, we need a new tool. What happens is they believe that these things are going to make them happy, give them the tools they need, when in fact they often don't understand the very tools that they're using. And that's because one of the things that we're facing today is what's called an atemporality. An atemporality is a period of transition. We're using the old rules with new tools, and we haven't come up with what the new truths are for today. So think of the old Soviet Union. People that grew up in the old Soviet Union, when it collapsed, they didn't have a new structure, a new norm. What is the truth? They went through a period where they were still operating off of how things were done in the Soviet Union, but they were no longer in that Soviet Union structure. They had to go through a period of transition to define what is the new norm. And whether you like Putin or not, it doesn't matter. The fact is he created a new norm that stabilized the country and gave them a new set of operating parameters. In a lot of ways, analytics is going through that same period as well. We are bringing in machine learning, deep learning, trying to build neural nets, and a lot of people really don't understand how they work, and we don't understand how we should apply them properly, socially, in an acceptable way. That new truth is still something that we as a society haven't defined yet, and it's probably going to be another 5 to 10 years before we get to that point. And it's just this thing where you're building these teams, you have to understand atemporality is just a way of life in this current environment, and it's okay to go through that phase of trying to understand where are we going next. So one of the concepts in this new data strategy structure that I really like is something that I actually learned from watching. You probably notice, if you're a fan of Ghost in the Shell, I've used quite a few of the images here, and that's intentional. And it really comes down to this slide right here. Ghost in the Shell is a great way of looking at aspect to aspect transition. In the West, we're very much focused on action to action in our data life, in our day-to-day life. We like to focus on what are we doing now, what are we doing next. But if you look at the original Ghost in the Shell, which came out in 1995, done by the Japanese, they use a very Asian-focused process of making that movie called aspect to aspect. If you look at most animes in that time period, you'll see various scenes where there's no action happening, and it's almost timeless too. It's really the examination of the environment. Whereas here in the West, if you watch the live action Ghost in the Shell, which I don't like, because what they did was they only scratched the surface of it, where they show you a few seconds, but if you actually watch the original 1995 Ghost in the Shell, they'll take like 3-minute long sequences showing you aspect to aspect. And in a lot of ways, when data science teams are in trouble, it's because they're always focusing on one action to the next. They don't spend time really examining the environment in which they're operating in, and understanding that environment and truly soaking it in. And that's something that a lot of teams need to start getting accustomed to, which is really understanding your environment instead of just focusing on the actions that you're taking. But one of the pitfalls I've also seen is companies are trying, when they create these environments, they like to create what are deemed utopias by somebody. There's this optimal like production or test environment, and everybody's going to go into that optimal environment. Someone's utopia is always someone else's dystopia. So you're always going to have somebody on your team who just says, this environment is horrible, I don't like it, I want to work on somewhere else. That's where heterotopias come in quite handy. Heterotopias are multiple environments, and I've done this myself where we've set up multiple environments for teams where they can configure it in any which way they want. They're allowed to use whatever language they want and bring in whatever tools they want and create their own space to do their experimentation in. Now, of course, this isn't the production environment. It's just a test bed environment. That allowed for more creativity and bigger bursts of products that moved into production than any other method I've seen so far. So that heterotopia environment is something that, for a data science team, I think is absolutely critical to have in place. And that comes down to the final piece, which is identity. We're often having these discussions in terms of what is data science, and our identity as a team and as an individual on the team is very critical. There is a lot around how we define ourselves within that space, and as an individual, we like to believe that we define our space. But when it comes to an analytical environment, our space often defines us as well. And understanding how your space is impacting you and influencing you in your overall structure of how you do your work is very important. And you'll find most data scientists and their teams don't even acknowledge the impact their space has on them. So now that I've gone through a bunch of what I would call theoretical concepts, let's just get down to more of the practical aspects of things. These are some of, like when I'm building a team, these are some of the slides that I would show as more of a practical, here's how you position your governance, your strategy, how you would put your teams in place, and where they should all belong and communicate with one another. This is pretty high level, but it tends to work and show how everything can really work together. Instead of just talking about theory, here's how it actually works on a practical level as well. But there's also concepts like data philosophy, where you're looking at data going from information to knowledge to wisdom. This is very important because data in itself is actually quite useless. It needs to be turned into information to have any value to anybody. I got a friend who works in the NSA, and he's always talking about all the data they collect, and then he tells me, don't tell anybody or I'll come after you. But it's like, I'm not afraid of you collecting data. I'm really concerned, what is it you do with that data that really freaks me out? That to me is the more important aspect. And the knowledge and what kind of wisdom do you get out of that data? Because data is always interpreted. We're always putting our own lens on it. No one's ever seen data on its own. It's always interpreted. So the interpretation someone puts on it to create the knowledge and the wisdom is also very important as well. And of course, when it comes to hiring, this is the big thing. Everyone that I talk to, they're always trying to find a data scientist who does everything. And you're not going to find that unicorn, to be honest with you. But you can create a unicorn-like team that does cover a lot of these different areas and covers a lot of the aspects around, like, how are you going to promote them? How do you make the most of those heterotopias and sell your mission? These are all questions you should be able to have answered when you're creating your teams around data science and using these data strategies concepts. So I know this was a lot of different concepts thrown at you, and I didn't expect you guys to all get them right away, but I do believe a lot of these concepts are concepts that are going to start growing more and more within the data science field, and I hope this was useful for you. So thank you.